Hi, I'm Geoff DeLizzio, the Chief Advancement Officer at the Lieber Institute for Brain Development and the Maltz Research Laboratory. I'd like to give you a tour. Let's take a look. So we are a brain research institute and nonprofit biotech. And I want to take you a look around because we are here to solve one of the biggest issues that faces people here, which is mental illness. 1 in 5 people will suffer from mental illness in the world. And of all of human history, we have not cured any brain disease yet. And we are here trying to prevent and find treatments for mental illness and age-related diseases. So come on, let me show you around. This is our med-chem lab where we do our medicinal chemistry, and it's where our teams take all of the great work that happens here at the Lieber Institute and we test it out. We create different molecules. We do a lot of iterations here so that we have everything on site that allows us to kind of move fast and figure out what is the best type of molecule that we can then turn into a drug that can help somebody that is suffering from some form of mental illness. And this space allows us to move fast. It allows us to collaborate and iterate very quickly. So we are really fortunate to have this much capacity here on site. And it allows us to then work with external partners when it's time to actually take this and move into larger productions of testing. Again, everything that we do here and the whole design of the Lieber Institute is about being able to be innovative and move fast because people need help now. And this space is a perfect example of this. Everything you could possibly need from a medical chemistry lab is right here. And it's really a fantastic resource that we have. Now we're moving into our main laboratory space, and I want to take you into where everything starts. We are humbled and honored to be able to have one of the largest brain repositories in the world with over 5,000 brains that have been donated since we've started. And this is absolutely critical to our ability to conduct research, make discoveries on the brain, and then prevent and treat these illnesses. And it all starts here. When the brain comes, it gets dissected in this space here. And we have a fabulous team here that is working on this. And what you're seeing here is they are taking these frozen slabs of brain that we have prepared, and they are finding the exact space within that brain to pull out different tissue samples that then are being used by all of the researchers here. Without this, we can't do any of this work to the level that we would be able to do it. This is where everything starts and where we are able to make most of our advancements in this research space. It is absolutely critical, and we are humbled to have this resource. Moving along, what we see here is all the various labs that we have in this space. And this is where a lot of our basic research happens, where we are making discoveries on the brain. There's a lot of equipment that we need, from centrifuges to various molecular analyses. And this is what we are allowed to collaborate quickly, work really well together, and again, have all of this under one roof. This is a very large space, very large footprint. There's a lot of equipment packed in here. And this is at the heart of what we do every single day. This is always a buzz with activity. There's a lot of people moving in and out, and it's really just a wonderful opportunity. I'm going to take you now into our microscopy lab, which allows us to get extremely sophisticated images of the brain tissue that our researchers need to do their work. So this space is dark for a reason. It allows our microscopes to be at the level of sophistication that they need to do this work. We also have an incredible range of high-tech equipment here that gives us kind of robotic advantage from a microscopy standpoint. Everything we're here is about innovation and speed so that we can help people now. I think one of the things about this place that I love the most is the level of sophistication of this equipment. It is so sensitive that the vibrations of the building, of walking around, of the HVAC system means that it would actually ruin the image because of the high resolution that these images are. So all of our equipment is floating on beds of nitrogen. That gives it that spring that allows us to actually conduct these experiments and these images in a way that won't mess up this really high resolution, which is pretty cool. Now we'll check out the Mayar Electrophysiology Lab. This is where we really study how the brain communicates, how neurons communicate with each other. We see how the things fire and build connections. And this really allows us to understand all of these connections that happen within the brain in disease states like schizophrenia or bipolar and other mental illnesses. And what's really great about this space is, again, the ability to not only have access to new technology, but actually be a part of establishing protocols for that. So most of this electrophysiology equipment was fairly manual. It was done one cell, one patch at a time. So any study that we were doing would be very painstaking and take a very long time. We now have access to this Nanion machine, which allows us to do hundreds upon hundreds of these patches, these cell studies at once. And it really does give us this robotic advantage to do things repeatable in a very efficient and very accurate way. It's been a fantastic addition to our operation here and to our researchers. So welcome to our stem cell lab, which is run by Dr. Tomoya Sawada. And this lab here is incredibly important because this is actually where we grow live stem cells to conduct research. And not only when we are collecting these incredible gifts of the brain from donors, we also collect the live stem cells, which allows us to operate this lab and allows us to grow these stem cells. In many cases, we're using them as brain organoids, which is like a mini brain, and allows us to run research studies on very specific disease states and allows us to do that with live brain cells, something that obviously we would not be able to do with a live human brain. So it gives us a tremendous capacity to increase our ability to research and study these disease states. It is such an important aspect of this work that we continue to grow this lab, and we can't wait for you to see it in the future. So around the corner here is our RNA sequencing lab. Every brain that comes in gets RNA sequenced, and it is the building blocks of how we understand that brain and allows us to set off on a journey to understand the mechanisms of the diseases that we're studying. This is an incredibly important part of the work that we do, and it allows us to have this kind of building blocks, this foundation before we even get started on any of the research studies that we have, giving our researchers a tremendous amount of data before we even start. Now, we're moving into more of the office space here, and we purposely designed this space to enhance collaboration amongst teams and amongst various labs within the Institute and the Maltz Research Laboratories. This is a really important aspect of what we do. We did not want to reinforce silos. We did not want to encourage people to kind of laser focus on their work and just do it. The innovation and speed comes from the ability to bounce ideas off each other, learn from other areas of the organization, and that allows us to, again, do that fundamental aspect of what we do here, which is innovate and do so with speed. Now we're going to take you down to our brain repository, and we'll kind of give you a sneak peek. Most people don't get to go and visit this. So back here is truly the heart of our operation. This is where all of the brain donations are stored. It is absolutely the most important element of the work that we do. And it is, as you can see, a very equipment and energy intensive operation to keep all of these brains in perpetuity frozen at negative 80 degrees Celsius. So this is really what allows us to do our work and do our work over a long period of time. I'm actually going to ask my colleague Nate here to open up one of these just so that we can see what inside one of our freezers look like. So these are where we store our brains, and I'd like Nate to go ahead and open this up for me. Again, this is what makes our research possible, and each one of these houses a series of brains that we have prepared that have been donated. And within each of these freezers, we have about 90 to 100 whole brains that are prepared for research. And we can keep these at negative 80 degrees in perpetuity. And again, this is very meticulously tracked, monitored, and requires a lot of attention to detail to ensure that we know where everything is, and we have a precision detail on everything. So thank you for joining me. This is all possible because of the generosity of our brain donors, because of these incredible researchers and the staff at the Institute, and because of people like you who support our work day in and day out. We are a nonprofit institute. We cannot do this without you, and we are grateful for you joining in our mission to prevent and cure mental illness. Thank you.